Hi there, my name's Brendan and this is my video on my final year project for Monash Uni, which I did in 2012, and it's called the Magic Pillbox. The project itself is basically a pillbox, as you can see here, which has a bunch of electronic components attached to it, a bunch of sensors which detects the status of the pillbox and communicates this to a smartphone app. This app can then send an alert to the phone itself, as well as an alert to another user, which is sent by SMS, and you enter that phone number into the app, which you can see here. The purpose of this is to really address the need for a simple and cheap medication monitoring system. There are many on the market at the moment, but we felt that there could be something that's a bit more user-friendly, a bit more familiar. As you can see with the pillbox here, it's a very familiar interface, and it's basically an off-the-shelf pillbox that we've just bought from a supermarket. So it's designed obviously for elderly people, but it could also be used by anyone, and as you can see, it's highly portable, and although it's a little bit big now, we hope that we can manage the size with further improvements later on. So the purpose of this video is to really demonstrate what I've done and have a look at potential improvements that could be made in future work. Rightio, so I thought I'd get underway by showing you how the system works very generally, and as you can see here, I've got my Samsung Galaxy S2 phone running on Android. At the moment we've only programmed it on Android, but obviously in future we look at developing an iOS app as well. And so we'll run the app itself. We go into apps, you can see here the Magic Pillbox app, so we'll press that. And just apologise for the camera resolution, as you can probably see it's not fantastic. And when you run the app, it connects to the pillbox itself, which is on as well. And via Bluetooth, it starts talking to our Arduino Bluetooth board, which we'll have a look at a little bit later. So as you can see here, we've got our app and a few data entry fields. So the top one here is, which you probably can't see, it says enter the phone number of a recipient. This is where you can enter a mobile number for where you want the alert to be sent to, so another phone number essentially. Over here we've got start time and end time. The way the system works is there are basically three time periods that it will look at, and it will poll the status of the pillbox every 10 minutes in order to cross-check with the particular time period that it is. So, for example, as we can see here, we have a start time of 4 o'clock and an end time of 6 o'clock. So if we haven't taken our pills by the end time, by 6 o'clock, then the pillbox will send an alert to this phone, as well as the phone number that we designate, and we'll see that in a minute. If the time is between 4 o'clock and 6 o'clock, then it doesn't matter whether or not we've taken a pill or not. So based on the status of the pillbox, it won't return an error message unless it detects that there has been a change in any of the other days. If it's before 4 o'clock, then we expect that no pills have been taken from that particular day. So today is Wednesday, and if in Wednesday's box we see that a pill has been taken before 4 o'clock, then it will also send an alert. If it's between 4 and 6 o'clock, then it doesn't matter whether or not there is a pill in there or not. If it's after 6 o'clock, which is the end time, then we expect that this box does not have any pills in it. Okay, so what I've done here is I've entered a phone number into this field here, which is the phone number corresponding to this phone. And what's going to happen is in about 30 seconds time, hopefully, it will become 6 o'clock according to the Android system time. And once it hits 6 o'clock, it will poll once again this pillbox. And because today is Wednesday, it would expect that there are pills, Wednesday's corresponding pills would be taken. So because we've left them in there, it'll generate an alert on this phone, as well as sending the SMS to that phone number, and it should appear here. And we'll show you the alerts and also the status of the pillbox, which gets sent to both these phones. So now we can see the SMS has just been sent. It's generated an alert here, and there's the corresponding SMS alert on this phone. So we'll have a look at the SMS first. We'll go down to it. Just a bit slow. And there, you probably can't see that, but it says the Magic Pillbox patient has not taken pills or unexpected pill error. And then it's got a pillbox status just down there, which you can't quite see. But there it is. That's the SMS alert. And as well as the local alert here, we get a notification under the pull down bar with also the status of the pillbox. So this alert will send twice. So there it is. It's gone again, just as a sort of safety net, and to reiterate the message. This, obviously we don't want to send too many SMSs. This is after the second alert, the program cuts off and doesn't send any more alerts until the next day. So the idea of this is, let's say we have an elderly patient. They'll get an alert on their phone, which will tell them the status of the pillbox. And then the phone number could be of a relative or a loved one, or even a nurse in a nursing home, for example, or a doctor, and they would get the message that something's gone wrong in the pillbox, and as an extra measure of accountability for the patient. So that's how the system works at a very high level, and now we'll have a look at the actual hardware and the components behind this system. Okay, so now we'll have a look at the hardware behind the Magic Pillbox, and as you can see here, we've got these little sensors in each compartment of the pillbox, and to have a look at them as a standalone, there they are. They're very simple, very cheap. It's a variable resistor essentially, and the more pressure you put on the variable resistor, the lower the resistance. Without any pressure, the resistance is almost infinite. So we utilize that in a comparator circuit, which we have here. Two LM339 quad-core comparators, and we put them in a circuit with these force sensitive resistors. We did a lot of tests to measure roughly how much pressure is required to actuate these sensors, and based on those tests we came up with a reference voltage, and that reference voltage is set as the trigger for these comparators. So once the pressure on these sensors exceeds that threshold voltage or the reference voltage, the comparator triggers a logic high, and vice versa. If there isn't enough pressure, then it's a logic 0. So then this feeds into the Arduino board, as we can see here, and there are 7 days, so 7 different inputs into the Arduino board. This is a Arduino Bluetooth board, so you can see, just seen there's a Bluetooth module, and that's what's used to communicate with our smartphone. And the program is quite simple. It's basically a loop which polls the status of the pillbox at a certain interval or certain rate. For today's example, we've used that rate to be polling every 1 minute, but in reality we would poll maybe every 30 minutes or 20 minutes to save power. So as it polls, it checks the status of the pillbox, and via that Bluetooth module sends it over to our smartphone app, which reads and decodes that status in Java. We can also see here there are 3 AAA batteries, and that's what it takes to power the Arduino board and the comparators. So you're looking at an ideal operating voltage of about 4.5 to 3.5 volts is ideal. And that's basically the hardware. just a quick evaluation of the Magic Pillbox. Number one problem, as you can see, is that the force sensitive resistors are circular and our box is square, or rectangular. So that means that there are sort of dead zones in there, as you can see. If a pill gets stuck in these little corners or areas where there aren't sensing mechanisms, then that does create an error. It's not obviously based on our time and money constraints. We didn't really have the capability to rectify that, but that's obviously an area which can be improved and pretty easily improved. Another option would be to look at other sensing methods, like I've seen induction sensors, capacitive sensors, flux sensors. They're a bit more expensive, but also potential options as well. Other areas to improve, obviously the size of the whole system. We can see it's pretty big at the moment, and I'd highly recommend that rather than using an Arduino board, we could use a much smaller programmable microcontroller and set up the interface between the comparator, the microcontroller, and the mobile phone and the Bluetooth module. So that's definitely another recommendation for the future. Apart from that, you'd be able to make it quite a robust system. This sponge mechanism, I forgot to talk about earlier. This is basically designed to actuate the sensors themselves. It was one of the more difficult things to come up with. So they basically squash the pills to create enough pressure to actuate the sensors. Obviously, with a bit more time and effort and resources, you'd be able to make a slightly better system than mine. But the idea was to really ensure that it's user friendly and simple to use, and having this very basic pillbox is something that patients seem to like and enjoy, because it's simple, it's easy. You just flick it open and you can just pop your pills out as you need. The other point I should make is that it's also portable. So when you need to go and exchange and refill up this pillbox at the pharmacist or the doctors, you can see here the force sensitive resistors are just attached, and you can just unplug them, as you can see, unplug all 7 of these, and you can take off this pillbox and just do a quick changeover at the pharmacy. So that's also a nice little point about what I've done. So thanks for watching my video, and hope you enjoyed my demonstration of the Magic Pillbox. Thanks. Bye.